My talk today is about how computers and software can be enhanced to create a device that can help medical documentation. I believe that much of this data that we are keystroking into our electronic medical record systems can be automatically picked up like an airplane's flight recorder. So this presentation will take you on a visual journey from science fiction to current technologies available today. Then I will present my idea for a medical documentation robotic system.
And as robots begin to interact with us, they need to be capable of perceiving and understanding our social nuances to effectively communicate with us. Researchers in the Personal Robots Group are exploring nonverbal cues to design robots capable of social syncing. Research in human social psychology has found that mimicry and synchronous movement behavior are building blocks in fostering trust and rapport between people. To model such behaviors, we need a full-body digital perception of how people move in a social interaction.
Basically, smart interaction is, simply put, voice, motion, and face recognition embedded onto the TV with the help of built-in camera and a microphone and our voice motion engines. Channel 64 being activated with my voice. Okay. You just have to hold up your hand like this, gently wave, and it will pick up the cursor on the screen, which is working just like a PC mouse. If you squeeze your hand like this, it means click or select. Very simple. Oops. And if you draw a counterclockwise circle like this, it will go back to the previous page. All I need to do is activate the face recognition mode, and it will recognize my face and it will log into my account automatically. And of course, you need to register your face first with TV. Hi TV, log in, and it will pop off the face recognition mode.
Thousands of surgeries are done at Sunnybrook every year, and success depends on having a clear roadmap of each procedure.
For all surgeries we do today, really, image guidance is a key to helping the surgeon. It's like having a GPS for your car now.
And now, surgeons like Dr. Law are getting a helping hand from an unexpected source, Microsoft's novel gaming system, Xbox Kinect, which turns the player into the remote control. Traditionally, surgeons remember in that moment the information imaging like CAT and CT scans provide, or they can step out of the sterile field around the patient to manipulate the image on the computer. But that means having to re-scrub. Dr. Law says the application they have built on the Xbox Kinect offers the potential solution to that challenge. The surgeon makes simple and measured gestures in the air and can remain in the sterile field while directly adjusting CAT and CT scan views.
You'll see me controlling the X-ray imaging completely without touching or interfacing with the screen or the mouse.
So we're here looking at the Leap. It's a 3D motion control device that allows for all 10 fingers to be used simultaneously.
Pause it, you can see everything's in 3D. So the 3D movements that my fingers are making in space.
Welcome to the Connect for Windows SDK. This video gives you a brief overview of the natural user interface capabilities that can be added to a Windows Managed Code or native application using a Connect for Windows sensor. By using a Connect for Windows sensor, you can build software that reacts to people's body gestures, voices, and other real-world events. The NUI API provides 3 levels of access to the Connect sensor data. There is direct access to the sensor. At a higher level, there is access to the data streams, such as color, depth, and audio. And at the highest level, there is access to process data, such as skeletal tracking. To use the NUI API, first get a sensor from the Connect Sensor's static property of the Connect Sensor class. Call the start method to initialize the object. Call additional methods or use events to get stream and skeleton data. The Connect Sensor provides several streams of data that you can access through the Natural User Interface library. Color image data can be accessed as a stream in either RGB or YUV formats. The depth data stream contains frames where each pixel contains the distance between the camera plane and the nearest object. The audio stream contains raw audio data from the microphones. And the player segmentation stream provides bitmaps where the pixel values correspond to the player index of the person in the field of view who is closest to the camera.
And it will start to track my face. So we'll pull back a little bit here and pull forward. There we are. So at the moment you can see that it's not only just tracking my lips, it's doing an entire face tracking task. And at the moment this little application goes ahead and reproduces my face as a little tiny smiley face avatar. All the way down to small eyes when I'm smiling and pulling back and frowning, and open jaw, and turning my face. It uses in conjunction not only with the RGB camera, but also the depth sensor. So after a minimum of 18 inches, it's able to discern where my nose is, because it's the closest to the camera, as opposed to my eyes and my ears and my eyebrows. As part of the documentation, there's some documentation here that shows this young man in the documentation here is showing where all of these points are. I guess there's. So with that, we'll see how far we can get, and as soon as we get some more things, we'll let you know.
There's also a NUI Skeleton API, which provides information about the location and pose of multiple players who are standing in front of the Connect sensor. The data is provided to the application as a set of points called skeleton positions. Note that there is active and passive skeletal tracking. Active tracking applies to up to 2 players in the field, and passive tracking applies to up to an additional 4 players. Active tracking shows the full skeleton, as shown here, whereas passive tracking only provides limited position information.
Hi TV, Smart Hub, and that's why I love the new Samsung Smart TV with smart interaction and smart content. It actually recognizes my voice and gestures, giving me access to all my favorite entertainment apps like YouTube, Netflix, and of course Hulu. It also recognizes my face and logs me into Smart Hub. Check this out. See? All my favorite movie apps right there on Samsung Smart Hub.